afternoon, ladies and gentlemen. My name is Haley Bennett, and I am a staff engineer at Intelligent Concrete, where we specialize in making concrete do the impossible. Today, I am continuing my resource consumption series. This is part 2 of many, and today we are going to be talking about resource consumption when you have exponential growth. Now, I'm going to give you a disclaimer that this is not the most accurate or even proper or correct, appropriate, whatever you might say. This is not the right way to calculate resources and times it would take to use up resources. There is a much better method and much better model that I will be showing you in the next video, so stay tuned for that. But for now, let's just jump into it. I am using this 3rd edition Introduction to Environmental Engineering and Science by Masters and ELA. We are in chapter 3, section 3, and it is all about resource consumption. So I'm going to give you a breakdown of the equation that we'll be using and then some givens, and then we will be answering 2 questions on coal resource consumption. So here is the equation for the time needed to produce a resource. So we have T, which is that time, 1 over R. R is the exponential growth in production, natural log, that growth again. Q is the total resource production from time 0 to time T. P naught is the initial production rate, and then plus 1. And then our givens here are that in 2005, coal production was estimated to be 6.1 billion tons per year. It is estimated that the reserves were 1.1 trillion tons, and that it was growing at 1.9% per year. So let's go ahead and get into the questions. Okay, so question 1 is how long would it take to use up the reserves that we have at current production rates? So we are going to go ahead and take our reserves, 1.1 times 10 to the 12th tons, and we're going to divide it by our production. Is 6.1 billion, so that's 10 to the 9 tons per year. Our tons are going to cancel out, and we are going to be left with 180 years. Now, I'm going to go ahead and warn you that this is not correct. This is not realistic, this is misleading, and this is not how you should calculate resource consumption. So let's do a much better model, and that is as if the growth was exponential. Rather than a bell curve or rather than any other model, we're going to do exponential for this part 2, and we'll get into other models in the future. But we're going to go ahead and use our equation that I had written before. I'll go ahead and rewrite it. So let's go ahead and find out how long it would take if our coal production continued to increase at 1.9% per year. So we're going to take we're going to do equals 1 over, our growth is 0.19% per year. So we're going to turn that into a decimal, natural log, 0.019 times Q, and that is our reserves. So that's 1.1 times 10 to the 12th tons. And that is all going to go over our initial production, which is 6.1 times 10 to the 9th tons. And that is all going to be plus 1. So the time it would take for our coal reserves to be all used up if production continued increasing at 1.9% per year is actually 78 years. Wowza. That's kind of scary. And it just shows that simply dividing your resource by your production is not really that accurate. And to be honest, this number isn't even that accurate. And we'll get into more accurate models and methods of calculating these things in future videos. But this is really eye-opening. And I will also be continuing to explain how this has anything to do with the concrete and construction industries. So stay tuned for that. Thanks so much for watching. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete, beat asphalt.